Good afternoon, folks. Hope you're doing well today. Got some new exciting trigonometry stuff today. We're actually going to use all that trig stuff that we've learned to solve a few problems in this lesson. So, hope you got your notes, found them, take them out, and here we go. So, section 4.8, problems with trigonometry. All right. So, first off, what you need to know in this lesson that it's critical to draw a diagram, okay? So, you have to have a diagram for basically every single problem. Otherwise, it's like you have no idea what's going on. So make sure you draw a diagram. All right. Secondly, there's two main types of problems here. Angle of elevation, where you're looking up at an item. Okay. There's my pen tools there. Sorry about that. So you're looking up at an item and you have an angle theta. Okay, and remember, you have to have right triangles to do these trig functions. All right, and then you have angle of depression when you're looking down on something, like this guy on a cliff looking down at the billy goat. Okay, I guess mountain goat maybe. All right, so here is the angle of depression. All right, now with angle of depression, you basically can turn it into an angle of elevation problem, because if you remember something from geometry, there's something called alternate interior angles. So angle here is equivalent to the angle down here, okay? So, I mean, the guy looking down has the same angle as the billy goat looking up, which is going to be useful here in these problems. Okay, so here we have a point 100 feet from its base. We have this Roman arch. We're going to try to figure out how tall it is. We have this angle, it's in degrees, which that is fine, except for we have also minutes and seconds, so we have to convert this to decimal degrees first. So let me remind you guys how to do that. All right, so you have to take, let me use a different color besides red, that's awful. All right, you have to take the 34 degrees, okay, then you're going to add it to, okay, there is 13 minutes, so there's 60 degrees in a minute, so you really have 13/60ths of another degree, okay? And there is 3,600 seconds in a degree, because there's 60 minutes in a degree, and then there's 60 seconds in a minute, so it's 60 times 60, so there's 3,600 seconds in a minute. All right, so then you need to calculate the decimal for this. So let me get my calculator and do that real quick. Okay, so we got what's 34.22 degrees. Now, if we're going to find the height, we have to figure out which trig function to use. So this is the angle that's given to you here. So h is the opposite side, and 100 is the adjacent side. So we have opposite over adjacent, which means we're going to be using tangent here. So we're going to do tangent of 34.22 equals opposite over adjacent. So that'd be h. H is not for the hypotenuse this time. H is for the height. Okay, so maybe you'd want to use something else besides h, I guess, if that is confusing to you. 100 is the base. All right, so now we're going to go ahead and get h by itself. So we need to multiply both sides by 100. So we'd have 100 times tangent of 34.22, and then you're going to put that in your calculator and see what the height is. And it should be reasonable. You need to make sure you're in degree mode again. So it should be a reasonable number, like something close to around 100. If it's not, then, well, you know something is a little bit off there. Like maybe you're in the wrong mode. But okay, I got 68 feet for the arch, so the height is equal to about 68 feet. It doesn't really say how to round here, so we'll just round it to the nearest foot for this problem. Actually, you probably should be more accurate on your homework, so like 0.0, maybe 2 decimals here, 0.01 feet. All right, let's take a look at the next one. Okay, sorry, struggling with this mouse here. Next problem here. Okay, so we have a buoy. Okay, it has an angle depression of 6 degrees. We're finding the distance x from the base of the lighthouse here. Okay, so like because we have that angle of depression, we could also use the alternate interior angle idea to realize that 6 degrees is down here as well, okay? So it's up to you if you want to use this 6 up top here, and then, it's draw another triangle over here, okay, and representing the 130 like that. Anyhow, so here, this is what's given to you. We're trying to find the distance this buoy, here's the buoy, from the lighthouse is. All right, and the lighthouse is 130 feet above the surface of the water. So, once again, we know the opposite and we know the adjacent, so we're going to be using tangent. Okay, so we're using tangent again to solve this. And this particular one, we are going to be multiplying both sides by x first to get the x out of the bottom there. All right, and then once you multiply both sides by x, you will then divide both sides by tangent of 6, and you see what the buoy is. Okay, about 1,237 feet from the lighthouse. All right, now we're going to get to a tougher one here. Okay, from the top of a 100-foot tall Outgelt Hall building, a man observes a car moving toward the building. The angle of depression changes from 22 to 46 during the period of observation. How far does the car travel? So we're looking for x, how far the car travels. Okay, now you cannot directly find x because this isn't a right triangle. So what you have to do is find a right triangle, okay, which if you extend it and go to the building, x plus d, the base of that forms a right triangle. So if we figure out d and we know x plus d, we can then subtract the two to figure out x, which is the distance from the building. Okay. So once again, we're going to use these alternate interior angles to make two triangles here. Okay, it might be easier for you guys to see it if you separate the two triangles out, but there's the one triangle we're going to be using, and then there's the bigger triangle here too. Okay, so first let's try to find d. Okay, so there's what the variables represent down there. So we're going to first try to find d. All right, so from the smaller triangle, all right, we're finding the distance. Here we got opposite and adjacent again. You're not always using tangent, okay? That's a lot of these problems do use tangent though, because the diagonal is a lot of times not what we're looking for, but sometimes it is. So anyhow, here we're finding the distance. The car is at the end from the building. So tangent of 46 equals 100 over d, because it's opposite of 46 over adjacent, which is d. All right, and this is another one where you want to start by multiplying both sides by d first to cancel off the d. You cannot work when you have a variable in the denominator. Okay, so you always have to get rid of that in the denominator. Okay, and then you need to get rid of the tangent with d, so you divide both sides by tangent. Okay, so you have 100 over tangent of 46. And then you would think to put that in the calculator, but for accuracy's sake, we're not going to put that in the calculator yet. We will put that in the calculator when we are calculating our final answer here. Okay, so this does represent some number. Now let's figure out the total distance it was initially from the building, which is x plus d, okay, because it's these two added together. All right, so here we have tangent of 22, because we're doing the big triangle now, equals 100 over x plus d. All right, here we're going to cross multiply. Well, actually, made me a liar here. Okay, so here we're going to multiply both sides by x plus d. It's kind of like we're cross multiplying, to be honest. Okay, and so this tangent of 22. Okay, so if you do it in two steps, you multiply both sides by x plus d. And then you divide both sides by tangent of 22. So we know x plus d equals 100 over tangent of 22. Now if we want to just find x, which is what we're trying to find, the distance the car traveled, we need to get rid of the d here, so we're going to subtract it from both sides. Okay, but we already know what d is. We found that right here. So we can substitute what it is, okay? And now's the time where you pick up your calculator and, for accuracy's sake, put all of this in your calculator, okay? Just make sure you're in degree mode, and you should get about 150.9, and you should label that, I don't know, is it feet? Yeah, 151 feet if you round up, okay? Pretty cool problem. All right, and here is the last one. This one's kind of a tough one. A large helium-filled penguin is moored at the beginning of a parade route, waiting for the parade to start. Two cables attached to the underside of the penguin make angles of 48 degrees, wow, and 40 degrees, okay, with the ground, and are in the same plane at a perpendicular line from the penguin to the ground. Okay, so with all that information, you should be able to draw this. If the cables are attached to the ground 10 feet from each other, okay, so there's like cable 1 here and cable 2 over here, okay? Hopefully you're watching where my mouse is going there, okay? How high above the ground is the penguin? All right, so kind of a similar problem to the last one, but this time we know this little distance here and we don't know the height, okay? So h equals the length of the side that the two triangles share. And so that would be this side. They're sharing this side. Nope, sorry. H is equal to the height. Oops, my bad on that. H is equal to the height. I don't know why we just didn't say that there. Okay. And so we can model this with two functions, one for each of the triangle. Okay, so we're going to actually set up a systems of equations here because we're going to have too many variables to solve. But h over x equals tangent of 48 because that's from the small triangle here. Okay, opposite over adjacent, tangent of 48. Okay, and the other one, 10 plus x. Okay, we can't just use 10 because that's not a right triangle. Okay, so we have 10x plus 10 on the bottom here, which is the adjacent side to 40. Remember, it's opposite h over adjacent, which is x plus 10, equals tangent of 40. All right, so we're going to try to get one of these equations solved for one of the variables and substitute it in. Okay, it's easiest to solve for h because you just multiply the first equation, okay, by x, okay, and then you'll get what we have here, okay. So this equation is what we get after you multiply by x. And since we now know what h is, okay, you can actually multiply by x plus 10 in the second equation. That makes it a little bit easier. Okay. We can now substitute what h is, which is x tangent of 48, okay, in for this h, and rewrite this equation so it only has variables with x. Okay, so since we have an equation with variables with x, you can now solve it. You have to try to get x by itself, so first we're going to distribute here. Alright, so we distributed the tangent of 40 in. Next, looks kind of ugly. Alright, so what I'm actually going to do here is I'm going to put the two x terms on the same side. So this term, I'm going to move over to the left by subtracting it. Okay, so now we have both x terms you see on the same side. Alright, so in order to solve this now, we have to make these two x's somehow into one. You cannot just take tangent of 48. In order to do this, you basically have to factor out the x, okay, in order to combine these two tangents. So that's what you did here. You did the x as a GCF. All right, and then you could actually do this in the calculator if you want, but then you lose accuracy. So what I did is I divided both sides by this whole big chunk here, okay? Put that underneath both sides. And then you put it in the calculator. All of this. Now, when you're entering the bottom in the calculator, you need to make sure to put parentheses around this, okay? And there you have it. That is going to be the height of Mr. Penguin. Actually, no, I lie. That's x. Okay, the height of Mr. Penguin is h, so we have to put this back in for x and work it out to find the height of the penguin. Okay, hope that helps you guys understand it. And I'm out of time on this video, so have a nice day, guys. Bye-bye.